Okay guys, I just want to give you a further insight. When we say that A over sine of A is equal to B over the sine of B, that's the sine rule, right? But I want to focus on this thing called inverse proportionality. A times the sine of B equals B times the sine of A. Okay, now I want to show you, now inverse proportionality, that's something you might remember. It takes 5 workers, 11 days to build a house. How long will it take 13 workers? And it's inversely proportional, okay? So let's just do the question like that. It takes 5 workers, 11 days to build a house. How long would it take 17 workers? And how long will it take 17 workers in time would come out like this. So this would be a smaller time. So when things are inversely proportional, their product, you see, then if A is inversely proportional to x, A is proportional to 1 over x, and therefore their product is a constant. Now this doesn't have to be 1, this can be any constant itself, and once you know this, then you can go x times x1 y1 equals x2 y2, showing that they're inversely proportional. So why am I going on about this? Well, I want to give you a kind of a guttural reaction to a question like this, that you can go really rapidly into the question. So if I go A, B, and of course point A and point B. So you have to be super careful here. If you go A is to B is the same as, then you have to come back this way because of the inverse proportionality, not continue on that way. So if you've got A over B, then that's the same as the sine of A over the sine of B. And you're dealing with the inverse proportionality by having two-way traffic through the proportionality. Just think of it that way. If you want to be really cool and really quick about it, then that's one way to think about it. Okay, so let's put a question in front of us. Let's take question 3 here. Let's strip away all the nonsense with the letters and say we have a side length 7. We have an angle coming off one of its endpoints at 23 degrees. We have 58 degrees, or S at 58 degrees, 23 at T. Oh, these questions drive me mad. So many stupid. So when you see RST, just go RST on an equilateral triangle. I mean, or any given triangle, it doesn't really matter. Just draw a general triangle and just randomly assign as quick as you can the 3 letters you've seen. Then do not use line segment notation, this sort of notation. It's rubbish. Why not just use little t? Okay, so think like this, because it's quicker and it's standard notation for a triangle. And then think, so in this particular case we'll kick off, once we've seen those 3 letters, we're going to go R, S and T, and then we're going to drop data in. So RS is 7, the angle at T is 23 degrees. It absolutely doesn't matter if it's completely way off regarding its depiction. Doesn't matter. Even if acute is really obtuse, doesn't matter then. Okay, and then at R we have 58 degrees. Find ST. So now, try and apply what I was telling you. So basically, if you're going to contaminate them, what I'm going to say is x over sine of 23 degrees equals 7 over the sine of 58 degrees. They go together.